Hey everyone, welcome back to the Foundations and Pre-Calculus 10 videos. In this video, we're looking at Lesson 7 from Chapter 5, which is talking about interpreting graphs of linear functions. So here we're just going to jump straight into an example, which is example number 4 from your notes. So this graph shows the total cost for a house called by an electrician for up to 6 hours of work. The electrician charges $190 to complete a specific job. So we want to know, for how many hours did she work? So here we're given a graph, and so what we can do is we can estimate our value. So here we can go to our total cost, which is our y values here, and we can maybe try to approximate where 190 is. And so here we're going up by 60, so this would be 180. So you're going up to just a little bit above, might give us $190. So you might want to go maybe right here. So you can estimate a value, which, I don't know, you might want to say it's 3.25, maybe 3.5. But because we're estimating here, we don't really know exactly what it is, so we could get that answer wrong. So what I would recommend here is that you should create an equation based off of this graph and then plug in your y value of $190. Okay, so in order to determine equation, we're going to use the general form y is equal to mx plus b, where x and y are your x and y variables, m represents your rate of change, which I'll call the ROC, and b represents your y-intercept. So what we need to do is we need to calculate our rate of change, and then we can find our y-intercept using our graph. So number one here, so your rate of change. So to find your rate of change, we do have an equation for that, and that is equal to y2 minus y1 over x2 minus x1. So then we're going to use our graph to find two coordinates, so that way we can use this for our rate of change formula. So the first one that we can go with is, and make sure you guys choose some nice values where you don't have to estimate those values. And so our first one here would be 0 and 60. And then another nice coordinate, if you guys are going along that line, would be this value right here, which is 3 and 180. So then one thing that I would recommend that you guys do, and one thing that does help me, is that I label my coordinates, because I find often that a lot of kids can get y2 and y1 mixed up, and I see a lot of calculator errors because they didn't put the numbers in the right places. So what I'd recommend to do here is that this one here is our first coordinate. So this is my first x coordinate, and this is my first y coordinate. So I'm going to call it x1 and y1. Then this is my second coordinate, so this is my second x coordinate and my second y coordinate. So then y2 is going to be 180 in your formula, y1 is going to be 60, x2 will be 3, and 0 is 1. So that way I know exactly where I'm putting my values in. So putting that into my formula, I have 180 minus 60. And then our x2 minus x1 is going to be 3 minus 0. So then looking at our formula, we have 180 minus 60, which can be simplified to 120. And then 3 minus 0 is just 3. Then we can divide the two numbers. They actually work out really nicely. If the numbers didn't divide, you would have to leave it as a reduced fraction. But in this case, 3 can divide into 120, and that there gives us 40. So then our second part here is that we need our y-intercept, which is our b value. So that one there we can actually just see from our graph. And here we're looking at the y-intercept, so you have to look at this y-axis and see where your graph intersects it, which is at this coordinate right here. So it's at 0 and 60, which tells us that your B value is equal to 60. So then from this, we can create an equation. So we had y is equal to mx plus b. So our equation is y is equal to, our m value was this rate of change, which is 40. We're going to leave x as it is, and we'll plug in the 60 for b. So the equation that we have is y is equal to 40x plus 60. So now that we have an equation, now we can go ahead and solve for one of our variables. So here we know from the beginning of our question that we want to know how many hours the electrician worked for $190. So here the charge was your y variable. It's on your y-axis. So we want to plug in that 190 in for y, and then we're going to solve for x. So what we're going to do is we're going to have 190 is equal to 40x plus 60. So what I'm going to do is I'm going to solve for my x variable. And so what we have to do first is we have to subtract 60 here. So you want to move all of the numbers to the other side. And I always start by doing, it's almost like opposite BEDMAS, where I want to do the adding, subtracting first. So here I'm going to subtract 60. And what I do to one side, I have to do to the other to make sure it stays equivalent. So 190 minus 60 will give me 130. That's equal to, and on our right side here, we just have 40x because 60 minus 60 makes 0. So then here we have 40 multiplying with x. So to get rid of multiplying, you're going to divide by 40 on each side. So 40 crosses out 40, so on our right side we just have x. And then here we can go ahead and put this into our calculators if you guys can do that in your heads. 130 divided by 40 is 3.25. So this tells us that the electrician had to have worked for 3.25 hours, or 3.25 hours in order to charge $190. And this one here is a word problem, so we do need to write a sentence for this. So we can say the electrician worked for 3.25 hours. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.